Welcome to our TechnoSessions. This TechnoSession is brought to you by Ashnik. Recently, Docker announced release of version 17.06. Today, I have Patrick van der Bleek with me, who is Solutions Engineer with Docker, and he is based out of Amsterdam. He's going to give us a peek into what are the great features in Docker Enterprise Edition 17.06. Welcome to Asia, Patrick.
Thanks for having me, Samir.
It's always great to have geniuses like you. So, Patrick, tell us about key features. What are your picks out of all the great features which are there in 17.06?
Basically, we chose a couple of pillars where we wanted to build our new features on. So basically, the pillars we've chosen for that was multi-architecture orchestration, giving our customers the freedom to basically move workloads towards containers, but not limiting them to Linux alone. We've been adding a lot of features in the pillar for secure multi-tenancy. So expanding our role-based access control so we can actually deploy containers at scale in a much safer way. Controlling who has access to what resource, being able to have multiple customers or multiple teams share the same swarm, but still separate them on a node level, for example. And the third pillar is basically on policy-based automation. So we're looking into automated promotion of images from dev towards test towards production. Multi-stage builds is an important feature. And we're adding new configuration APIs for our UCP management interface.
Oh, and that is just your favorite picks. There are a lot more features which are there in 17.06.
Indeed, there's a lot more, but those are the ones that I talk to customers about the most.
Wow, great. You mentioned about Windows containers and System Z support. That is really exciting. So does this mean that I'll be able to run my Windows applications on a Linux box?
No, you're not going to run your Windows applications on a Linux box because, of course, the Linux application is written towards a Linux architecture. The same goes for Windows applications. However, Microsoft has spent an enormous amount of time over the past 2 years building the similar capabilities as Linux has been having for years into their Windows kernel. So things like C groups and namespaces are actually now available inside the Windows kernel. They're called differently, of course, but they are there. Which means that we have been able to adopt our libraries underneath the Docker engine to talk to those specific subsystems in the Windows kernel. So you can now actually deploy native Windows applications in a native Windows container on Windows Server 2016. All with the same command line interface, all with the same user experience. Okay. And we can actually now share those clusters with mixed hybrid setups between Linux and Windows systems in one single cluster.
Well, and if I'm a heavy Windows user, let's say I have a lot of applications which are running natively on Windows, and I have some Linux containers already running in my environment. So when I start containerizing my Windows application, the look and feel of the Docker environment itself is going to be pretty much same.
It's going to be almost exactly the same. So there's going to be tiny bits and pieces that of course work differently on Windows, but the command line interface is going to be the same. The way you manage those from UCP is going to be almost the same. And we've spent a lot of work in getting feature parity across both platforms inside the Universal Control Plane and DTR as well.
Oh, okay, wow. So does that mean that you mentioned that it is going to have the same look and feel even in UCP? So does that mean that I can have a Windows worker node working alongside a Linux worker node?
Absolutely.
And I can span containers across them, or applications which are spanning across them, some components. Wow.
So if we look at what the one of the features that was added in Windows as well is overlay networking. And overlay networking, as you might know, is the basis for Docker Swarm. Overlay networking is where the DHCP and DNS internal service discovery happens, etc. So Microsoft has been working hard to get overlay network to work on the Windows Server platform. And actually, when they came out with their first release, they implemented compatibility between Linux and Windows as well. So you can have one overlay network span Windows and Linux nodes. So your containers, which if you have a stack of containers running a Windows application and a Linux application, those containers can talk to each other across the same overlay network. So you can actually completely build hybrid setups of applications of multiple software architectures.
Wow. And will I be able to run containers even on my ZOS machines?
Well, yes. If you look at what we currently do on ZZ has been announced a couple of months ago at DockerCon. It has been available since the release of 1706, the engine. So you can actually add a mainframe system running any form of enterprise Linux into your swarm and manage it from UCP and DTR as well.
But it has to be a Linux.
It has to be a Linux. So if you look at the native Z system, operating system, ZOS, there's only 2 operating systems in the world today that have those capabilities in their kernel to run containers. That's Windows and that's Linux.
Okay.
So yes, it's going to be Linux on the mainframe, but we support all the major Linux vendors that are available on the Z system.
Okay.
So it's going to be RHEL, SUSE, Ubuntu, all available and supported.
And you spoke about role-based access control, which has been enhanced in 1706.
Yep.
I believe that feature has been there in UCP and DTR for a very long time, since the very beginning itself.
Absolutely.
That was one of the main topics I used to go and talk to customers about. I remember having implemented that for one of the customers here. So how things are different in 1706?
The role-based access control that was in UCP earlier had a couple of rough edges. It worked pretty well. We had a couple of defined roles ranging from no limit to full control. But those roles were set in stone. They came from the product and you couldn't customize those roles.
Okay,
so
I know what you're saying. Yeah, I had customers asking that, hey, can I define my own roles? Can I put my own limits, or can I put my own segregation of duties? I can define things. Okay,
correct.
Now I understand.
So in UCP 2.2, which is part of the 1706 release, you can actually start creating your own roles. We call those grants. So you can set up a user or a team of users, and you grant those users specific access to specific systems.
Okay.
So that's been added. So another important feature that we've added is what we call collections.
Okay.
So in the previous release, you would have to set labels on all of the resources you would have under role-based access control. In 1706, we've got something which we call a collection, and you can add all kinds of resources from your swarm into a specific collection, and then attach grants to that collection. So it's on one hand making it more advanced, giving you more freedom to set up your own roles, and on the other hand making it a lot more easier to implement those roles.
So can I also go to a level where I can add nodes to these collections?
Yep, indeed. So that's one of the special features we're really proud of that we've been able to add as well. One of the most asked features if it comes to role-based access control.
Yeah.
So we can now bring role-based access control all the way down to the node level. So I can add a specific node in my swarm to a specific collection, and then the role-based access control will make sure that my users can only deploy their applications on nodes which I've given them access to.
Wow.
So that's increasing the enablement of multi-tenancy within Docker EE.
Wow. And then I can also have like 2 ops team which are across geographies, and they can still use nodes which are distributed across geographies. Or if I have segregation within my team, like dev team and QA team, that's fantastic.
Yeah.
Wow. Okay. You were talking about the policy-based automation, but I believe in today's world, most of the enterprises already have some kind of CI/CD pipelines which automates the way the images are built. And these CI/CD pipelines don't just do the application builds, but I have myself worked about a year's time. I have been working with a customer to automate their image build process and integrate that with their Jenkins CI/CD pipeline. So all that is already automated. So how is this policy automation going to work with that? Is it going to replace that? Is it going to augment that?
No, it's going to be an addition to traditional continuous integration. So let me take you back. What happens in a typical continuous integration pipeline? We pull the source code. Yeah, we start building our application. We do a Maven build of a Java application, for example. Then we take those artifacts and we start a Docker build process. Yeah, we build the image and we push it to our repository. 9 out of 10 times it's going to be a developer repository, and we want to move that forwards towards a dev, or a test repository. So what typical users do is they run a bunch of tests to see does it integrate well, does it run, etc. And if all those tests pass, they re-tag the image and push it to a test repository. Works pretty well, especially for the developers. But IT operations has no control in that. So IT operations wants to know, okay, is that image still safe? Does it have any does it introduce any new security vulnerabilities, for example? That's what policy-based automation is bringing to the table. You can automate promoting an image from dev to test based on a set of criteria that you can actually run inside Docker.IE. So Docker.IE scans your images for you. You can set it. You can set your policy that if it finds more than X amount of security vulnerabilities, or if it finds any critical or major security vulnerabilities, it will block the automated promotion. If all passes, if all tests passes and all criteria are met, we can automate the promotion to the next repository.
That's awesome. So now operations teams has less things to be worried about. They don't have to go and scrutinize images themselves or do some kind of hardening test themselves.
Indeed, they can be part of the automation this time.
That is also awesome. So this is some automation for the operations team. While CI/CD is helping developers build images and build the application real quickly, now operations team can also join the party and have some automation. That's awesome. Okay. You mentioned about Windows containers earlier, and now we are talking about image scanning. So is this feature of image scanning available even for the Windows containers, or is it only for Linux containers?
So what I told you earlier, where we were focusing on when we put up the multi-architecture operations, one of the focuses we had in mind, we need to be on almost feature parity with Linux and Windows workers. So the user experience should be the same across the board. So indeed, for image scanning and the Docker Content Trust, so the signing of images, so you can actually verify the origin of an image, and if it's been changed in the meanwhile, has been extended to Windows as well. So you can automatically scan all your Windows images for vulnerabilities, and you can actually put signatures on Windows images, making sure you can trust your images throughout your organization.
Okay, that's really good to have the same kind of feel and same kind of features across different architectures. That's really nice. You were talking about the new APIs which have been introduced, and I have checked them out myself. I recently installed UCP, the latest version of it, and I went to the APIs page and I checked out there are a lot of methods available for getting stats about containers, for deploying things. So how do you think this will help enterprises who are running like a lot of containers or a very large cluster, more than 20 nodes cluster? How do you think it will help them?
So there's a couple of use cases this is helping. First of all, one step back, we've had APIs available in the product for quite a while. So DTR has a full open API. The Docker engine, of course, has a full open API. UCP, which is basically our management infrastructure, that didn't have an open API just yet. However, UCP is adding a lot of functionality on top of your Docker runtime. So that UCP is the one that adds all of the role-based access control features, for example. UCP integrates with your native Active Directory or LDAP environment. Those are the things that a runtime doesn't do out of the box. We provide additional software to do that for you. Customers are coming to us and they want to be able to automate the installation of an entire cluster. They want to be able to replicate the configuration, for example, if they have multiple clusters spread across multiple locations, and they want to be able to replicate those settings automatically. That's the reason why we opened up the Docker API, the UCP API, so users can take a look in that API, configure, for example, all of the role-based access control settings, configure how to connect to their Active Directory or their LDAP, and a lot of other configuration items in Universal Control Plane itself.
Okay, that's really interesting. And when you have a lot of nodes and you're spinning containers almost every day, automating that process and doing that from, or integrating that another orchestrator, or monitoring all these things from another tool could be a very nice feature, and all that can be now available, possible by these open APIs.
Indeed.
That's great. You know, I have a customer who has been running Docker in production for a little more than a year now, and they've really got hooked to it. They're really liking it. They have started putting almost everything in containers. They are rolling out new services, and that has been really helpful for their business transformation as well. They're not complaining about it, and they're really liking it. But one thing which once in a while hits them is they have to go back and do something on housekeeping. It is becoming more and more tedious to manage and maintain this environment. So is there something which is being introduced on those lines to ease that pain, or is it something going to be introduced in future on those lines?
Well, next of course to the management user interface that UCP provides, which makes managing a large-scale environment a lot easier, because let's be honest, we're talking thousands of containers. It's going to be really difficult to manage those from the command line. So there's a lot of great management features in the UCP interface as well. In regards to housekeeping, in regards to runtime, we've added a lot of enhancements to the engine as well. So the underlying Docker engine has a lot of additional enhancements as well. One of them that's noteworthy to mention is we've added the ability to check logs for an entire service. So until recently, if you wanted to troubleshoot a service which was consisting of 10 replicas of containers, you would have to look into, okay, which replicas do I have, pull the logs from that specific container and start troubleshooting it. Is it something that happened in another container as well? Pull those logs in, take a look at those as well. You would have to look at all the containers separately. So with the addition of Docker service logs, we can actually pull the logs of all replicas in one single service. That makes troubleshooting a lot easier. You can see in one overview what the containers are actually doing. Is it just one container that is failing? Is it all of them that's failing?
Okay.
So that's one important one. Next to that, we've got what we call Docker Prune, which is already available in the earlier version of the Docker engine. So which basically helps you clean out all of those resources that you're not using anymore. Stopped containers, dangling images, just being able to remove those on a frequent basis, making sure you keep your system clean. We've added the option to actually filter things in Docker Prune. So now normally Docker Prune would just run and it would throw away every stop container that was on the system. Now you can actually start filtering on labels. So if you only want to remove stopped containers from a specific service, just look at the service label and apply a filter to Docker Prune for that specific service. Okay. For example.
That makes life a little easier.
Yeah,
of course.
Yeah. So
can't say no about it. Yeah.
So there's a lot of other great enhancements in the Docker Enterprise Edition engine as well. One of them that I find most interesting, and I know you're pretty psyched about that one as well, is multi-stage builds.
Oh yes, I've read about the multi-stage builds, and I've seen developers who struggle to write a Dockerfile, which becomes overly complex over a period of time just because there are a lot of dependencies which has to be first added. Then you do a build, you build your software, let's say a jar file or a Go application, and then you have some more steps to get rid of those things which you had added just for the build purpose. And all this causes a lot of images to be created, and your whole build process is very lengthy. And it is also a very complex Dockerfile.
Yeah.
So tell us how these guys are going to have an easier life now.
Yeah, so basically what we introduced with multi-stage builds is, as the name says it, you can define multiple stages in your image build. So we mentioned before, let's take an example of a Go application.
Yeah.
During the Docker build process, you're going to actually compile that application. What do you need to compile the application with? A Go compiler.
Yeah.
Go libraries. All of the stuff that you only need at compile time for that specific application, because at the end of the line when you're going to run your application, the only thing you need is that specific executable.
Yeah.
But if you do a one-stage build, all of those compile libraries, compile tools is going to be in your end product. It's going to be in the end image. So what multi-stage build does is it allows you to run a first stage of the build process on a full-blown image which contains all of those compile tools, compile libraries, etc., etc. Run the build of your application in that stage, and then throw in a new stage. But this time we're going to start a stage from a really tiny container that doesn't have all of those libraries and executables inside. And then we can copy that executable that was built in stage 1 to the next stage, resulting in a really minimal image. Just a couple of layers, depending on how big your final stage of your build process is, of course.
Wow. So that means that in my Dockerfile now I can have multiple from statements, and in one of the from statements downstream I can refer to the previous from, the image built by the previous from, and borrow some or copy some files from there and use it for my final image build. That's awesome. That's nice, and it also gives a very neat look to my Dockerfile as well. Be much beautiful now. Right?
Yeah.
Okay, that's awesome. So that's great. So to conclude, I guess I would say that this release of Docker is gonna make it even more friendlier for developers and for operations team both. I can see that there are some powers now being given to the operations team as well to vet the images or to go and check the potential risks in an image and automate all that promotion that we talked about, the policy-based promotion, and the idea that this is not just for Linux containers but also for Windows containers is a very powerful notion. And this hybrid architecture is also great. That means that from my UCP controllers I can give instructions to deploy containers across any of these nodes, and it is just going to work like as it works on Linux. So there's the same kind of commands,
same user view,
same user interface. That is awesome. So I think this release, in my opinion, is taking Docker one more step towards making containers available for everyone and making it possible and useful for everyone. And this is really about transforming IT to keep supporting your business transformation, keep supporting the digital transformation stories people are doing these days. So I would say, to summarize, this is a really great build from Docker. This is a really powerful release from Docker. If you have not already tried it out, go ahead and try it. If you need any kind of help, support in evaluating this version of Docker, or if you would like to know more about how you can put your applications in container or run hybrid applications in a Docker UCP environment, just write to us. You can get in touch with us on success@ashnik.com, and we would be really happy to help you out. We can also do some demos for you to just give you an idea of how powerful this technology is. And stay tuned, we'll bring more such stories to you. Thanks a lot for joining us today. Thank you, Patrick.
Thanks, Leah.